Welcome viewers. In this video we'll see the 8 to 3 encoder, also called octal to binary encoder. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic 8 to 3 encoder. Because of 8 it is given as octal to binary encoder. We know that the encoder is nothing but a device with 2 to the power n inputs and n outputs, right? The input is 2 to the power n, the output will be n. This is the basic structure of the encoder. Here n is 3, so 2 to the power 3 is to 3, that is 8 is to 3, right? We are having 8 different inputs. From that we can get the 3 different outputs. That's why it is called a 8 to 3 encoder, also called as, because of 8, octal to binary encoder. So the 8 inputs, let us consider the 8 input: y7, y6, y5, y4, y3, y2, y1 and y0. These are all the 8 inputs. The 3 outputs are a2, a1 and a0. So based on the value of these 8 inputs, we can get the 3 different outputs. 3 digits available in the output means we know that 2 to the power 3, there are 8 possibilities will be there. 0, 0, 0, 0, 0, 1, like that. 8 combination we will get based on the 8 inputs. Each input line corresponds to the each octal digit and 3 outputs generated corresponding to binary code. So that it is called a octal to binary code. Because of 8 inputs, it is represent octal digit. Because of 3 output, it is represent binary code. The diagram shows the logical symbol of octal to binary encoder. Now we'll see how we are getting the 3 different output from the 8 different inputs. Now we'll refer the block diagram. First we'll refer the block diagram. So this is the 8 to 3. This is not here 3 to 8. It is 8 to 3 encoder. 8 to 3 encoder. The 8 different inputs are available starting from y0 to y7 and 3 outputs a0, a1, a2, right? Now we'll see how we are getting these 3 different output from the 8 different inputs. So this is the truth table is available. The inputs are y7 to y0, then outputs a2, a1 and a0. We already discussed 3 digits mean 2 to the power 3, 8 combination will be there. That is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. Right? First 4, the third digit is 0. We have 0, 0, 0, 1, 1, 0, 1, 1, like that. Right? Then how we are getting this? If y0 is 1, all other digits are 0, we'll get the first combination 0, 0, 0. If y1 is 1, other digits are 0, second combination 0, 0, 1. y2 is 1, then other digits are 0 mean we'll get the third combination 0, 1, 0. y3 is 1, then other digits are 0, fourth combination 0, 1, 1. Then y4 is 1, other digits are 0 mean fifth combination 1, 0, 0. y5 is 1, other digits are 0 mean sixth combination 1, 0, 1. y6 is 1, other digits are 0 means seventh combination 1, 1, 0. If y7 is 1, other digits are 0 mean eighth combination 1, 1, 1, 1, triple 1, right? So based on the value of y0 to y7, we are getting 8 different outputs. y0, y1, y0 1 means other terms are 0. If y0 is 1, first combination, y1 is 1, second combination, like that we are getting 8 different combinations, right? This is the truth table of the 8 to 3 encoder. Now we have block diagram, then we discuss the truth table. Now we can develop the logical expression for a2, a1 and a0. Then that logical expression can be implemented with logic gates in order to get the 3 outputs. Now we'll see the logical expression for these 3. See, first we'll refer a2. These 4 digits are 1, right? First 4 digits are 0. What is this 4th digit mean? y4, y5, y6 and y7. These are all high level. So we can add y4, y5, y6 and y7, right? y0 to y3 we got 0 output, so no need to add. Only these 4 outputs are 1, that is corresponding from y4 to y7. So y4, y5, y6, y7 are added for logical expression A2. Then A1, first 2 is 0, second 2, next 2 is 1, that is corresponding to y2 and y3. So it is connected y2, it is added y2 and y3. Next 2 also 0. Then another next 2 is 1, that is y6 and y7. So y6 and y7 is added, right? y2, y3, y6, y7 are added in order to get the logical expression A1. For A0, see that first is 0, 1, 0, 1, 0, 1, like that. It is alternatively we got zeros and ones. So this one refers y1, this one refers y3, this one refers y5, this one refers y7, that is y1, y3, y5, y and y7, right? y0, y2, y4, y6 are zeros, so no need to add. Alternately we are adding 1, 3, 5, 7, right? So now we got the logical expression for these three outputs A2, A1 and A0 based on the truth table. So this is nothing but now we need to implement with the logic gates. What is this expression? All are added together, y7, y6, y5. So we need a OR gate. We need one OR gate for A2, one more OR gate for A1, one more OR gate for A0. So this totally we need 3 different OR gates in order to implement this logical expression. Now based on this we will see the logic gates, logical diagram, how to implement this 3 with the logical diagram. So this is the logic diagram. We are having 3 different OR gates are available. OR gate means it will add, right? So here the input lines are available. y0 is not, y0 is not available, right? So that we are not drawn y0. y1, y2, y3, y4, y5, y6 and y7. 7 inputs are available. y0 is not available in any of the logical expressions, so that not drawn. So first we will see the A2. A2 means y4, y5, y6 and y7. Right. y4, y5, y6 and y7 are connected together. So that we got this logical output added. All are, because of OR gate, all are added together. For A1, it is connected y7, y6, then y3, y2, right? y7, y6, y3, y2 are connected, so that we got this logical output for A1. For A0, alternatively, y7, y5, y3 and y1. These 4 inputs are connected together, so we are getting the corresponding output, right? So we got A2, A1, A0 as a 3-digit output with 8 combination. So automatically based on this value we'll got the output. For example, y7 is 1, we'll got the output. y6 is 1, we got the output. y5 is 1 or y4. Because of OR gate, any one input is high, we'll got the high output. Similarly here also, right? So in this video we discussed 8 to 3 encoder, also called octal to binary encoder, because of 8 input and 3 output. We discussed the block diagram, truth table, logical expression, then logical expression is implemented with the logic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.